Good morning, everybody. Jeff, can you hear me?
We can hear you great, John.
All right, thanks, Jeff. So, welcome everyone. Welcome to our latest webinar in the our Red Hat FAA webinar series. This is a series we do just for the FAA to show you many Red Hat products because we want you to use our Red Hat products, right? You have an enterprise agreement, so we want you to consume those products. So, many of you know me, many of you may not. My name is Jonathan Beach. I am the FAA dedicated solution architect here at Red Hat. So anytime you guys have any technical type questions, feel free to always reach out to me anytime. I'm always available. So today we have another great webinar prepared for you today. A few months back, you may remember my friend Tony Bowe came and presented to you OpenShift, right? From a very en route level view of OpenShift. But today I brought one of my other friends, Danish. He's here to, get into the TradeCon level view of OpenShift and kind of show it from a developer's perspective. But before we get started with Danish's presentation and demo, some ground rules. So by default, we mute everyone's microphone and camera so we cannot see you. So feel free to roam around the room, go get something to drink. We won't see you leave. And that said, you guys, I encourage questions, right? So on your right-hand side of your screen, you should see a Q&A button section. Please feel free to drop in any questions you have into that Q&A section. And then during the presentation, Jeff and I will be answering any questions you may have. And Danish, during the presentation, will be taking pauses to answering any of those questions that Jeff and I cannot answer. And if there's something that all three of us can't answer, we'll definitely reach out to you after this presentation and follow up with an email. You can also chat with us if it's not a question. There should be a chat button there on your right-hand side as well. Feel free to tell us what a great job we're doing. We always appreciate hearing feedback, whether it's good or bad. Let's see. That's everything I have. So, and like I said, in that chat section, I will be dropping my email address in there if you don't already have it. Just the way you have it in, for future reference. Jeff will drop his in there, and I'll even drop in Danish's email just in case you have any follow-up questions after the presentation. So let's get started, right? So today I welcome Danish Hussain. He's a specialist solution architect here at Red Hat. He focuses a lot on emerging technologies. One of those is OpenShift. But let Danish tell you a little bit about himself, and I'll hand a microphone over to him. Danish, welcome to the FAA.
Thanks, John. Can everybody see my screen?
See it.
Perfect. So once again, thanks, John. My name is Danish Hussain. I'm a specialist solutions architect supporting Don and through him the FAA. And I know it sounds like a fancy title. All it really means is I focus from a technical perspective on everything OpenShift and some supporting products as they relate to OpenShift as well. And today I'll be giving you an overview of OpenShift. So before we get into that though, in terms of an agenda, I'm going to be covering a few things here. First, we'll level set by talking about why even consider containers and just talk about some vocab there. We'll talk about how OpenShift can help you. Then we'll talk about some OpenShift core concepts. And this is really just so that when I'm going through the demo, there's nothing I say that kind of throws you off. And then we'll leave time for questions and follow-up. That being said, like John said, feel free throughout the meeting, ping us with questions. I'll take some pauses, see if we can answer some of those questions, and we'll keep moving things along. So what are containers? And I'm sure some of you have probably heard of this term of containers before and potentially even Kubernetes, but essentially what a container is, on the left-hand side of the screen, we can see like a kind of bird's eye view or architectural view of what a container architecture looks like. And the big difference really of containers versus virtual machines is just that when in a virtual machine, in each one, you have to package that guest operating system along. With a container, we can take that out of the equation and just run the container itself without needing that extra guest OS in each container. And the big benefit of that right off the top is it's going to be a lot more lightweight because now with containers, there's no guest OS, so it's just an application code and the dependencies needed to run that application. And the bigger benefit that brings to us in this new multi-cloud world we find ourselves in is that it's portable. And the portability is really important because now if I wanted to run things in, let's say, AWS, Azure, or on-prem, or whatever cloud you can think of, oftentimes the VM provisioning steps look something like somebody's opening a ticket, requesting a virtual machine, then an administrator or somebody in ops is provisioning some storage, setting up the networking, and then the credentials and passing back that VM, right? So sometimes it can take a couple hours, sometimes it could even take days, right? So it's a little bit of a clunky process. With containers, once you have that underlying infrastructure set up, you just move that container wherever you need to, and it'll just run there. We kind of take away some of those steps and some of those hurdles that it takes to kind of speed things up. And if we look at this from a DevOps perspective, the containers are great because they're fast to deploy. They only take seconds to deploy, and it's easy to iterate and introduce new versions of code and constantly keep upgrading things as we move along. And that being said, right, virtual machines aren't bad. They're still going to stick around. Containers are just an alternative way to package our applications that bring along certain benefits, especially when we start looking at things like deploying things in the cloud. Now, on the right-hand side of the screen, there's a lot of different benefits listed there. The overarching idea is whether you're a developer, somebody in IT ops, or business leader, containers can bring you some sort of benefit. That being said, though, you've probably heard of this idea of a monolithic application, which is the typical way applications have been written in the past. And with monolithic applications, all your application code for a single application is kind of together, and you really only need maybe a couple virtual machines to run it properly, right? Maybe just one or two, and just the two just for redundancy purposes. Now, with this new world of like microservices, you're starting to break apart your application into many different components. That brings along some big benefits, such as you have all these loosely coupled application components. So if one fails, your application could still probably function and maybe just have a small error versus taking down the whole thing. It's also easier to upgrade individual components, and now people can be free to use the latest and greatest languages to write an application component because they just have to make sure the components can communicate and you're good to go. But that introduced some new challenges, which is from an operational perspective, I was only managing one or two VMs before. Now I'm going to manage, maybe dozens of containers. So how do I place those on servers? Where do I place them? How do they find each other? How do they communicate? And how do I set up any sort of security rules or policies to limit access or just make sure those are secure? So while containers are great, they do introduce their own set of challenges. And that's where this tool called Kubernetes comes into the picture. So Kubernetes is a container orchestration tool it's an open source tool that has become the de facto standard for container orchestration in the industry. And what container orchestration is essentially, it makes life easy to the point of all I have to do is give a container to Kubernetes and Kubernetes figures out where to place it. So in terms of an actual application here, we'd, for example, tell Kubernetes, hey, you have these 3 servers available to you to run applications on. And that's all you have to do. And that creates what's called a Kubernetes cluster. Then from a developer point of view, all you have to do is hand a container over to Kubernetes, and Kubernetes will figure out where to place that workload for you and make sure that it can talk to other containers, that the storage is configured, etc., taking out a lot of the work you have to do. And it does that by looking at the available resources you have on each server, so things like CPU, RAM, etc. Of course, these rules can all be configured by you to maybe fit better with whatever your organization needs. But that on its own just solves one problem, which is the container orchestration piece. To then start utilizing containers and have a container platform for your entire organization to use in terms of, hey, I wanted to add a CI/CD tool, right? So all those things in blue. I want to integrate a CI/CD tool into my Kubernetes workflow. I want to get monitoring information on my Kubernetes cluster. I want to get some logging information on my workloads. What about authentication? How am I doing role-based access control? How am I limiting what people can and can't do? Are there any sort of application services available for me as a developer if I want to kind of glue my microservices together or start using more container native frameworks for my application development? Right, and how is that networking actually set up inside of my cluster so my containers can all talk to each other? And oftentimes we'll find when organizations get started with Kubernetes on their own or try to take a DIY approach, they run into these roadblocks of, okay, I need to hire additional people or I have to take it onto my own plate to manage that integration between these various components in blue and then to that box in green, which is that Kubernetes service. And then you need to have multiple people to handle each one of these components. They have to manage the life cycles. Then, okay, what happens if I try upgrading the monitoring project or tool that I integrate into Kubernetes? Upgraded the monitoring component, and then it breaks. So I have to figure out managing that. And then handling updates then for all these various components, handling updates for Kubernetes. And that's kind of where OpenShift comes in the picture. We at Red Hat handle managing and delivering a platform to you that integrates all these components for you, so you can just focus on writing code and delivering applications. And just to give you an idea of, in terms of all the various options available to those things in the blue boxes on the previous slide, if you look on the top right here, I know it's a little bit hard to see, but this is currently what's available in terms of monitoring tools for Kubernetes. So not only do you have to then, for each one of those separate areas, pick a project or a tool out of each one of these and then integrate that into Kubernetes, you have to then manage them as well. So it can get a little bit overwhelming, especially because, once again, it's a new technology and there's a lot of options to do and a lot of different ways to do a lot of different things. And we kind of make that easier for you by giving you that prescriptive approach. And that's where Red Hat OpenShift comes into the mix. OpenShift is a application platform for not only your traditional applications, but also your applications of the future. So thinking of cloud-native applications or applications leveraging AI/ML or a mix of both, OpenShift can support those. Additionally, it can run on any sort of deployment method that you choose. So whether that's physical, virtual, private cloud, public cloud, edge deployments, OpenShift can run across all of those. And what we've essentially done is, if you think about that previous slide where I listed, hundreds of projects, we've essentially, for each one of those various fields, so whether it's networking, RBAC, storage, security, app services, we've essentially looked at each one of those and picked, after doing a lot of testing, what we think is the best of breed in each one, and we handle delivering that platform to you. So you can just focus on writing code and delivering and deploying your applications. Now, in my opinion, OpenShift has a couple of really big benefits in this multi-cloud world we live in now, which is, first and foremost, it can run on all of those different infrastructure options. But the real beauty of it is, regardless of where it's run, OpenShift is going to give you the same look and feel. So let's say, for example, you are running some things on-prem, maybe in AWS and Azure, and you're utilizing Kubernetes and all of those. Well, then what's naturally going to happen is you're going to start using the tools available in each of those cloud providers, but they're specific to those cloud providers. So let's say one day you want to move some workloads from AWS to Azure. Well, it might not necessarily work the same, and you'd have to go learn how things work in Azure. Same thing with on-prem, you'd deploy things in Kubernetes, you'd then integrate your own projects, but then it would all be different from what you're using in the cloud. With OpenShift, you just deploy OpenShift on-prem, you deploy it on AWS and Azure, and it gives you that consistent platform so that when you go to deploy a container or an application, any one of these, it's going to look and feel exactly the same because we take care of talking to the individual infrastructure provider under the hood for you. The other big benefit here is, if you're somebody who doesn't want to learn containers or Kubernetes or get into any of these new things, that's totally fine. With OpenShift, we abstract away that complexity that comes with these new technologies, and you can just focus on deploying applications and writing code right from the dashboard. And I'll show you what that looks like in the demo here in a bit. But overall, I'd say the big takeaways in this multi-cloud world that we live in now, having a consistent platform across all the clouds for application deployment and maintenance, as well as building it, is extremely important. And with that, I'll hop into some OpenShift and Kubernetes core concepts. Just going to be a quick 5-slide thing, just so that when I go through the demo, I'm not saying anything that doesn't make sense to you. But I will pause here. John, are there any questions?
We're good. No questions yet.
Great. So you've heard me say container a couple times today. What is a container? So it is just the smallest compute unit. Think of a container as, once again, your application code and all of its dependencies, and a container is while those are actually running or the process is there. Containers are created from container images. So that application code and its dependencies and libraries, those are put into what's called a container image, and that's when it's static, it's just a binary file. When it's actually running, and that process is actually going, your application is running, that's when it's actually a container. Now, container images are stored in what's called an image registry, so that's just think of that as a repository for your images. An image repository contains all versions of an image. So, for example, on the left-hand side here, we have this front-end container image. As we introduce new versions of it, so we have the 1.1, the 2.0, and the latest, we'll actually store the previous versions as well. So if you ever need a rollback, it's easy to do so. And the reason we can do this is because containers images are so lightweight, it doesn't take a lot to store all the versions of a container image. Last slide here is that containers are wrapped in pods. And pod is nothing more than just metadata that we've attached to a container so that when we're doing things like container orchestration or networking or whatever it is, we can just attach the metadata to the pod and not have to actually interfere with your application code that's running in the container itself. So throughout the demo, I'm going to be saying pod often. When I say pod, just think, okay, pod is a container. And if I say multiple pods, it's just multiple containers. And it's just so that things make more sense during the demo itself. And with that, we'll head to the demo. Now, in terms of what I'll be showing you in the demo today, we'll essentially be looking at the OpenShift dashboard. I'll walk you through a couple of pieces there, but the big focus is really going to be looking at things from a developer's lens and understanding, if I'm a developer, do I have to understand containers? No, you don't. We can do everything through the dashboard. We'll fix an application, we'll deploy an application. You get to see something called CodeReady Workspaces, which is think of it as an alternative to VDI, but it's essentially workspaces that are all wrapped in containers that sit in OpenShift for you. And we'll get to see OpenShift Pipelines, which is an integrated CI/CD tool that's now part of OpenShift. All right, and John, can we still see my screen on OpenShift now?
Yep, looks good.
Okay, so this is the OpenShift dashboard. Now, there are two views here. There's an administrator view and a developer view. The great thing about that is developers and administrators and ops are all going to the same place now to do their work, so it helps people kind of speak the same language when oftentimes, on different teams, there's often some silos there. Now, I'll walk through some sections here on the administrator side, but first what I wanted to highlight here is we are sitting on this OpenShift cluster or instance is sitting on AWS. The reason I bring that up is because they could have provisioned this demo instance for me on Azure or on Google Cloud or on-prem, wherever it is. And the only thing that would have changed here is that the provider name would have been different, but everything else would have been exactly the same. So I would have been comfortable demoing this regardless of where it's deployed. And I'm driving that point home because especially as you start in an organization going to different clouds, having this consistent platform so that people don't need to relearn things unique to each cloud is extremely beneficial. So the administrator view here is going to be for pretty much everything related to cluster configuration and administration. So for example, if we wanted to update the cluster, it'd be as simple as hitting update here, and this would kick off an over-the-air update. If we wanted to do some sort of user management, so let's say importing your users and then setting policies on what they can and can't do, it would integrate with whatever identity provider you're using now, and then you can set roles and role bindings, which is essentially setting rules on what people can and can't do. If you wanted to, let's say, look at monitoring information on our overall cluster, we can do that as well. So quite a few dashboards. This is all customizable to whatever your organization's needs are. Additionally, we can set up metrics and alerting so that if your CPU usage is too high or your memory usage is too high, you can get alerted on things like that as well, though you can get a lot more nuanced with those controls as well. If you wanted to add compute nodes or storage nodes, we can configure the networking from here as well. Pipelines is OpenShift Pipelines, but I'll spend more time on that on the developer side of things. We can also see all the running workloads in our cluster here. So here's pods that we were talking about earlier. So these are all the running containers I have just in this demo instance that I'm going to show you in a second. But I want to spend some time here on operators and the operator hub. So before I talk about the operator hub, what an operator is essentially it's a way in software through Kubernetes that we can take all the day one and day two logic of operating an application and put it in a piece of software. So in terms of an operator, think of like a application operator. We can essentially codify that and put it into an operator. So things like installation, um, just general management, things like maybe security upgrades or just version upgrades, tearing it down, gathering metrics. We can put all of that information for an application into an operator. And the big benefit of that is then with Red Hat OpenShift, you have something called an operator hub, which is not only Red Hat, but also other big vendors, or just any vendor really creates operators. So if we go to, let's say MongoDB. So Mongo has created an operator for us. And essentially what you can do is you can install this operator. And then on the developer side of things, there's a self-service catalog where you can then utilize this MongoDB operator to spin up instances of MongoDB and manage them via the operator. So this can get you kind of thinking in terms of, hey, in my own business, how can I utilize operators and what vendors or products am I currently using that already have operators, right? So there's a variety of database operators here. So you may notice that some you're familiar with or already using. If you're doing anything in streaming and messaging applications, for example, Red Hat's integration suite is installed through an operator. If you wanted to, for example, get Red Hat Advanced Cluster Management or ACS, which are our multi-cluster OpenShift management tool or our container security tool, those would actually be installed right from the operator hub as well. You'd simply click on the product, hit install, and then the operator would handle installing it for you. In fact, the let's see if I can find. So pipelines, which we'll be talking about today, that CI/CD tool that's been integrated into the platform, I installed that via an operator, took about 30 seconds, as well as CodeReady Workspaces. That was also installed via the operator as well. So Operator Hub is a really powerful space here in OpenShift, and it can really help teams kind of hit the ground running and make ease of management of application components or applications that you get from vendors a lot easier. And with that, we'll hop over to the developer view. So here we have a developer view where on the left-hand side of the screen, it's changed. It's a bit more curated for what we find developers use more often. And I'll go through each of these sections in a bit here, but what I wanted to focus on first was this topology view. So what I have deployed for this demo is a 3-tier application, a Java frontend, a Node.js server, and then a MongoDB database. Additionally, we have an event listener here. And what I'm going to do is, so what the application actually looks like, if we hit this, this will pull up the application. So it's supposed to show park information. Currently it's just spinning. That's because I actually broke it so that the Node.js server and the front end aren't communicating properly. What we'll actually do is we're going to fix the Node.js application here, and then we're going to push that fix into GitHub, which I'm using for source control. And this event listener is actually listening and looking at my Git repo. And when a change is made, it's going to kick off a automated pipeline, which we'll see here in OpenShift pipelines. That's then going to pull my new code, build it into a container image, and then deploy that container. And we'll then see the park information actually populated there. And the best part is the application will never go down. We'll wait till OpenShift waits till your application component is ready to be upgraded, and then it'll just kind of seamlessly switch that for you. Now, before I get into actually changing anything here, if you think about this topology view, right now we have a simple 3-tier application, which you could say, hey, I don't really need any sort of visual. It's a simple application. I can remember that in my mind. But I've seen applications that have a dozen components or dozens of components where everybody's working on their own individual pieces. And the problem that arises there is nobody really knows what the overall application architecture looks like. Everybody knows their individual pocket of components that they're working with, and having a visual like this makes things easy because you can see how things are related. You can access them. You can get information here, which I'll show you in a bit. So let's pull up CodeReady Workspaces, and we can actually pull it up directly from the component itself.
Donish, while that's loading, I have a couple questions if you want to take a pause.
Yeah.
So the first one, not really related to applications. However, Keith has a question about air-gapped environments, OpenShift clusters, and upgrading those. How is that done in an air-gapped environment?
Yeah, great question. So OpenShift works in a fully disconnected environment, and in terms of doing or air gap environment, and in terms of installations, you would just have to pull the relevant upgrade data or upgrade files from whatever sort of uh, you use to pull things whenever you have that kind of gap to do upgrades, and then just point OpenShift to wherever that server is sitting. So as long as you pull those files, point OpenShift to it, you'll be good to go.
All right, good. And then we have a second question. Again, I think it might be something we take offline as a
Mhm.
follow-up conversation. However, what is the process of moving a monolithic application to OpenShift? They have a requirement that the application is running on a cluster and where to put the persistent storage. And again, you might get to that question as you go along. I'm not sure.
Yeah, so another great question. And so typically the best way we see, or the way I've done things often is, so you have this application, and what you start doing is you start taking little pieces of that application and putting them into their own containers. And then you set up the APIs so that now in that application, for example, let's say it's some sort of a, I don't know, shopping site, for example. You could, let's say, take out the transaction processing function and replicate that into a container. So now this container just has the code for that one component. And then you have the components in the application that would leverage that transaction function to actually then point to the container via some sort of API. And then you slowly start piecing components off of the monolithic application till finally everything's been containerized. And then you can just do a hard cut over to those components that have already been serving traffic for you anyways. And then in terms of persistent storage, so OpenShift can serve or work with whatever storage you want. There's file storage, object storage, block storage, and I'll actually go back into OpenShift and show you what that looks like in a second, but it will work with those, and then you would just connect those and make that storage available to OpenShift, and then your applications would be able to access it. Cool. Any other questions, John?
I think that answers it. There was a follow-up question about the monolithic one. I have a three-tier application. How do I get that to fit in OpenShift? And I think your demo here kind of shows something like that, correct?
Yeah. So
Yeah.
this is actually a three-tier application that I'm using right now. So this is a Java front-end application. This is a Node.js server, and then a MongoDB database. So I'm actually doing that for you right now. But definitely, if you wanted to do a follow-up conversation, we can do that, and we can dive more into your application and think about the best way to containerize it or move it to OpenShift if that's of interest.
Perfect. Thanks. Go ahead.
Great. So this is CodeReady Workspaces. Now, before I get into showing you what this is, what it is in terms of conceptually, CodeReady Workspaces is essentially workspaces that are containerized and then orchestrated by OpenShift for you. So it makes life for administrators or operations a lot easier because now you don't have to manage VDI or any of that. You can essentially just get CodeReady Workspaces via the operator, which takes about 5 minutes to install. Then you just spin up a CodeReady Workspaces instance. And the resource utilization here is great because these workspaces are created on the fly. So we have some pre-configured stacks, which I can actually show you here. So if we go to create workspace, we have some pre-configured stacks here. So if I wanted to spin up a workspace for Node.js, I could do that for C++ or C, I could do that PHP, Python, .NET, and some other ones as well. If you're using JBoss EAP or Red Hat Fuse, so I can create these workspaces by just simply clicking this. It'll pull up a workspace that now has all the libraries needed and all the tools needed to kind of get to developing for those respective languages. In this case, it's for Node.js. Once it pulls that back up. And while the workspace isn't being used, it's taken down. So, and in terms of how you access these workspaces from a developer, you just go to the CodeReady Workspaces URL, which is sitting up to this dashboard, and then that's kind of all you need to do. You can also configure it via YAML. so that you have a workspace that's pre-configured with the stack you want that accesses the GitHub repo that you want, which I've done for this. So it's a really great feature, and a lot of people have started to adopt this. And in terms of the actual look and feel, if you used Visual Studio Code before, that's pretty much exactly what this is, just sitting in your browser. All you need to utilize this is just some sort of connectivity via browser to your OpenShift cluster. And it's fully compatible with all VS Code plugins. So if there are any plugins you really like to use, I think they're VISX plugins is the format, fully compatible with those. So just think of this as VS Code that's hosted on OpenShift, kind of on demand for you for your developers. So what we'll do now is let's take a look at my file structure here. So the server.js file is all the routes for my node server. All I did to break it was I just commented out all the routes so that the Java front end wasn't able to communicate with it. So let's go ahead and uncomment those. We'll go over to the source control here. I'll enter a commit message. So uncommenting server routes. And then we can push this. And as I push this, I will stop sharing for a moment so that I can not have my credentials show on screen. Just give me one moment. There we go. John, can you guys see my screen again?
Good.
Perfect. So I pushed that code up. Now if we go back to OpenShift, you go to pipelines. So I made that change. I pushed it to my GitHub repo, and we had this trigger sitting on OpenShift to detect that change. So now it's going to fetch the code. It's going to rebuild it into an image and then deploy it for me. And we won't see any loss of service to the application. So for example, if I click on this now, it's still this Parks application. It is broken once again, but once the container's been updated, we'll be good to go. So while that's running, let's take a look at what we can do here from a day 2 perspective. So I'm a developer. I've edited some source code. I've pushed that source code up. Now, what about day 2 operations? So what we can actually do here is click on an application component. So click on Node.js, and it pulls up a bunch of things. So there's a details tab, a resources tab, and a monitoring tab. So on the resources, you can see the pods that are running. You could have multiple instances or multiple pods running for a type of application, and that's mainly for load balancing purposes. So let's say I had 2 pods. OpenShift would handle routing those and load balancing those to either one of those pods for you. So all you have to do is scale up the pods, and we'll handle doing the load balancing for you behind the scenes. And under pipeline runs, you can see that we have this running pipeline now that got triggered when I made that change to my source control. But let's go to monitoring. Actually, in fact, better yet, let's go to, okay, we'll wait for this. So it's tearing down my other container. Okay, so it did that. We should now, I'll give it some more time to switch over. So while that's waiting, let's go back here to view logs. So one of the great things about OpenShift is you can view logs right from the dashboard. Now, if you were just using Kubernetes, the way this would be done is you would have to do some sort of Kubernetes get pods command. You then have to figure out which one of your pods you wanted to get logs for, and then display those logs in a terminal. Once again, if you want to stay hands-off from a terminal, you don't want to get involved with containers or anything like that, you can do everything from this dashboard here. So we're able to view the logs here live from the dashboard. Right, great feature. Developers oftentimes love this, so they don't have to go anywhere else. They can just stick to where they're doing all their work. Additionally, if you wanted to open a terminal into a container, we can actually open a remote shell for you here. So if I did, let's say ls, you can see these are the same files that we were just working with in the CodeReady Workspaces. Right, so you can do all sorts of things here. Additionally, if you wanted to, let's say, view the YAML for your pod. Now, one thing I didn't mention is everything in OpenShift and Kubernetes is defined in YAML. So whether that's how you're deploying your applications or your OpenShift pipelines, or really literally everything. It's all defined in YAML. So if you wanted to actually go in and edit the actual YAML itself, let's say change the IP address or interface for your pod, you could do that here, hit save, and it would reload that for you. And then, yeah, we can see metrics as well. So memory usage, CPU usage. I think I'm using the old version of container that isn't running. So let me actually go back to that. You can also see details for the pod. So I did mention earlier that Kubernetes and OpenShift decide for you where they're going to place a workload. So if you made 4 servers available, it would pick for you the best one. If you're curious as to where that was actually learning, you can do that from here. To do that via just Kubernetes in the terminal, you'd have to once again get the pods, get the nodes, and then correlate what node the pod is sitting on. So this makes it easy to figure out kind of where things are running. Some additional information here that we don't really need to get into. It's just more details about the pods. Now, we can also take a look at pipelines. So OpenShift Pipelines is once again that integrated CI/CD tool that is fully available in OpenShift for you. It's really easy to use. So if you don't have any sort of CI/CD tool, or you're new to using containers and want to have a new CI/CD tool, that's where I'd recommend OpenShift Pipelines. If you already have your own workflow utilizing, let's say, Jenkins, for example, I'd say just stick with that. And you can actually get and host Jenkins on OpenShift via an operator. But if you have nothing, or you're looking to change or use something that's maybe more container friendly or Kubernetes native, OpenShift Pipelines is a great choice. So this is the one that's for the Node.js server. What this pipeline does is it actually just clones the code, it builds it into a container image for us, and then deploys that code for you. Now, to actually create a pipeline, there's 2 ways. To do it yourself, you would just hit create pipeline. You go to this visual pipeline builder, and you can see that there's a variety of tasks available to you. So if you wanted to do a git clone and then, let's say, add another task after, which, let's say we're building it using this tool called Builda, and then let's say you wanted to use the OpenShift client and deploy the code, right? So you can create something like that. You can also add tasks parallel. So let's say for some reason, while you're building this code that you just pulled, you want to pull some other code, and then maybe kick off a Maven build, right? So it's really easy to do visual, and then you can also add parameters that you can feed to the code itself. So really easy to get started with this. And then to add that trigger that was looking at the GitHub repository, all I did was I hit add trigger here, and I selected GitHub push, because for me, I'm using GitHub. If you're using GitLab, we have a lot of integrations with GitLab actually as well, or Bitbucket. Those are available for you as well. And then I just hit add, and that was it. Go back to the topology and see if this. All right, perfect. So this is the park information that's now been populated since our node server is now reachable. So we're going to just dive in here. So pretty simple app. It was more just to illustrate us, fixing that code and then automating that pipeline kickoff. But that was the application that we were working towards. So once again, what we did was, we edited that source code via CodeReady Workspaces. When we pushed that code into GitHub, it kicked off that automated pipeline for us in OpenShift Pipelines that was here. And once that was done, once it was ready to be built and deployed, OpenShift seamlessly switched over to the new container. We didn't experience any loss of service, and then we were able to see that our application was then fixed. So pretty straightforward. Now, let's talk about how I actually deployed these things. We go over here to add. So there's a variety of options here to add things, and that's kind of the theme of OpenShift, is we leave kind of the flexibility to you to decide how you want to do things. So the way I deployed things was I actually used this from Git method, and you feed it a Git repo URL. So why don't I actually just use mine? So all I did was I fed it my Git repo URL. This is for the Node.js server. And you can see it auto-detected that we were using Node.js and this thing called the builder image. So what this does is something called the source to image build. And this is, once again, if you don't want to get involved with containers, you don't want to build container images yourself, This is a great option for people to get started right away with deploying things on OpenShift. You just feed it a Git repo URL. It finds it looks at the code. It determined that it was a code for Node.js server. And what it'll do is it'll actually take our source code and inject it into this Node.js, what's called a builder image, which essentially is just the Node.js, all the packages and libraries you need to run it. And we just add the source code in there. And then I just hit create. I actually added this pipeline as well. And this is actually the pipeline you saw earlier. So it automatically has this pipeline by default if you want, which will pull the code, build it, and then deploy it. So I often see people when they get started with OpenShift and containers and they don't want to get into building container images themselves. This is a great option. You can see we support a variety of builder images that we support and certify ourselves. Now beyond just that though, we have quite a few other options. So take a look at the developer catalog. This is the catalog I was alluding to earlier when we were talking about operators. This is a fully self-service catalog for developers. So as a developer, if I wanted to, once again, let's go back to that Mongo example, spin up MongoDB. This is actually how I did it. I utilized this MongoDB template. There's quite a few here. There's a lot of templates you can find out. You can then import those into OpenShift. Templates are great because let's say I wanted this Apache HTTP server. I could simply click on this, hit instantiate template, give it a couple parameters, and then it would create a Apache server for me. Now, the great thing is if you and your organization are constantly deploying the same thing, but maybe changing a port or a protocol or just some minute detail, but having to redeploy or modify that code yourself every time, you can just templatize it and put that template in OpenShift. And that way, then whenever somebody wants to create it, they would just go to their self-service developer catalog, hit instantiate, fill out the form with whatever parameters you have set here, and OpenShift would deploy that for you. Additionally, if you've got things from an operator, so if we go to operator backed, currently I'm only using OpenShift pipelines. So these are things that you can deploy through OpenShift pipelines. So if you wanted to manually deploy a trigger, this is via that OpenShift pipelines operator. We could deploy that as well. If you, for example, got a MongoDB operator, then MongoDB would show up here and you can fully manage the lifecycle of a MongoDB instance that way. Same thing with everything else via the operator. You can do all of those things right here as well. So, for example, some other ones. Right, so there's quite a few templates. A lot of these are provided by Red Hat, but there's tons that the community have made, other vendors have made, and also you as a team or organization can make as well as it suits your needs. That being said, we can also deploy things via container images, of course. So if you actually have a container image, just point OpenShift to the link to your container image, and we'll handle deploying that for you as well. And we can also do things through Helm charts. So what a Helm chart is, if you're new to containers and Kubernetes, a Helm chart is a way to package a full Kubernetes application. It's a really popular way to do that. And there's a ton of Helm charts out there in the communities, open source communities. So, and actually a lot of just tools have Helm charts for them as well. So you can easily import those into OpenShift and make those available to your developers as well. And yeah, I think that's good on how we can add things in. Now, if we go down to monitoring, this is to get monitoring information on our entire project. And one thing I didn't mention was OpenShift does work on this model of projects. So for now, I just think of a project as another team, and each team has their own applications within a project. But you can look at monitoring information for the projects here. Additionally, if we go down to these things called config maps, what a config map is a way to kind of pass environment variables in to a running application. So if we hit create config map, it's essentially just a key value dictionary that we pass to an application. That way we can pull out that information that we're typically hard coding into applications. So you can see here, for example, example.property1 is hello, and you have all these other things for config maps. And then if we do secrets are a way to pass sensitive information to applications. So think maybe a user token or a database token. And to actually get this demo running, I passed the MongoDB secret here, these MongoDB parameters. I just hit add secret to workload, and I passed it to this national parks, which is the Node.js server. And that's how that Node.js server had the credentials to access the MongoDB backend. So really powerful tool to enable sharing. And the great thing is, if we go back to the administrator side of things, you can control access to secrets and what people can't do via roles and role binding. So you can really lock down things as you see fit. And I'll pause here for a second for questions before I talk about storage. John, do we have any more questions?
I do. First one should be an easy one. The National Parks demo, that's publicly available in GitHub, correct?
Yes, it is. It is.
Yes,
I modified a few things myself, but I just forked the public repositories
okay.
to do this
Yes.
demo. Yeah.
Dan, we'll send you the link for that. The second one is a two-tiered question, again from Keith. So they have a beefy server, and we cannot deploy OpenShift on a single node Linux thing. However, we can virtualize it. So that was his first question.
Yep.
Smaller resource, or doing VMs versus smaller resource nodes, more efficient. I don't think we Red Hat don't really have a preference, correct?
Yeah, it's definitely up to what you want to do. And actually, I think as of the latest OpenShift 4.9, it's either Tech Preview or GA is our single node OpenShift clusters. So we do have a single node option. I believe it's GA. Can get back to you on that. So we do have a variety of methods for deploying OpenShift. So there are smaller ones for, like, let's say edge use cases, but in terms of whether you're going bare metal or virtualized, oftentimes we'll see things virtualized. For example, if you're deploying in AWS or Azure, they deploy everything on their own VMs in there anyways. So we'll often see people deploying OpenShift on, let's say, VMware on-prem. And then the only time I really see people going bare metal is they had some need for maybe higher performance or doing some sort of AI ML workloads, or if they're utilizing, let's say, GPUs, something like that. But otherwise, typically we see it deployed on virtualized servers.
Okay, and then Keith's follow-up question. There's already an existing control plane set up, and I only apply that question to compute nodes. I'm not really sure what he's asking. Maybe you understand. But Keith, we could definitely follow up with you after this, and have maybe a conversation or an email chain going back and forth. We can answer some of these questions.
Yeah, I
in more
think what I'll
detail.
just say in terms of high-level architecture. So the way OpenShift works is you will have 3 control plane nodes, and then you would have as many worker nodes as you want, which are typically for compute. So 3 control plane nodes, you could have 10 compute nodes. Once again, it's kind of up to your needs and requirements that you have, but more than happy to follow up on by email or have a follow-up conversation to discuss that architecture.
That's all I have.
Perfect. Okay, last thing I'll cover, this is just on the terms of storage here. So the way OpenShift operates is in this concept of, and this is a Kubernetes concept as well, is persistent volumes and persistent volume claims. And this is how, if you're using OpenShift from somebody just using the platform, you don't have to worry about where OpenShift is deployed. Because essentially what you'll do, whoever's configuring or setting up the OpenShift platform, they will create persistent volumes, which essentially tie to actual storage. So if you're in Amazon, it would be that S3 storage. If you're on-prem, it'd be whatever NFS or file block storage you're using. And if you're in Azure, whatever it is there, I think it's Azure Blob. I could be wrong on that one. And then you create a persistent volume out of that. And then as an actual user or a developer, all you would do is create a persistent volume claim. So let's say you requested a gig of data. You could make that request, and as long as there's a persistent volume available that has enough storage for you, they would just bind together and you'd be served that data. So the benefit of this, once again, is as a developer, whether I'm using OpenShift on AWS or on-prem or in Azure or wherever it is, all I'm ever doing is working with persistent volume claims and making those data requests and then getting that data. I never have to worry about the underlying infrastructure. I leave that to the people who the administrators who initially connected our OpenShift to storage via persistent volumes. And I think that was about all I had today, John.
Okay, I have one more question here for you. What is the best
Mhm.
storage option for in-house OpenShift installation?
Um, I don't know if I'd say there's a best. I think it's kind of more on what you're looking for, but I think in terms of storage, you'd want at least a minimum of SSD tier storage. But beyond that, it's kind of up to you how you want to do things. And I'm more than happy to have a follow-up there to kind of discuss what you're trying to accomplish and look at that. But at a minimum, OpenShift does need SSD tier storage. And that's not an OpenShift requirement. That's actually a Kubernetes requirement because of the way it stores cluster state. So that's just what they need as an SSD so that your cluster functions at a speed that isn't too slow. Cool.
All right. All right, Danish. Well, with that, I guess we'll wrap things up. Again, Danish, that was great. I loved every time I see you do this. I love seeing it. I learn more every time you do it. So, thank you, Danish, for coming out and doing this for us today. And with that said, and like we were saying earlier, we will be following up with a few of you with your questions. But if anybody else ever wants to have a deeper dive and ask Danish some more detailed questions or to see a different type of demo, always feel free to reach out to Jeff, myself, or even Danish. I put his email in there as well. Um, and like that, like I said with Danish, thank you. But there are a few others that work behind the scenes to make this happen today. Um, as always, Jeff Thompson and Catherine Brady, work behind the scenes, sending out the invites, making sure everybody at Red Hat, gets these invites and attends. So thank you both. Also, our partners, CDW and DLT, they host a DLT portal. They work also behind the scenes and really plug this webinar as well. Thank you guys. And with that said, the DLT portal, we do put up a recording of this presentation, so you can go back and view any of our webinars we've done in the last 18 months. It's a really great resource. If you missed something or you want to go back and watch it again, that's the go-to place. We also put up there the PDF of the presentation as well. And again, I will post that up probably early next week. And with that, let me plug my next webinar. It'll be Jeff and I's last webinar 2021. And we're going to kind of mix it up a little bit with the holidays in late November and December. So we're going to put it early December this time. We'll do one more. And we're going to try to do something related to Ansible. So we skipped September's webinar for Ansible Fest because we didn't want to overload you with too many videos. So during Ansible Fest, we unveiled Ansible Automation Platform 2.0. So I'm going to try to do a high-level overview of some of the changes in that update, as well as do some quick demos as well. So look for that invite. Again, it'll be early December. We haven't decided on a date, but most likely the first or second week. So from myself and the rest of the Red Hat team, thank you, everyone from the FAA for coming out and watching Danish's presentation today. And we look forward to seeing everyone again in early December. With that, I won't talk to you guys again before Thanksgiving. Hope everybody has a good holiday, and we'll talk again in about 6 weeks. Thanks, everyone.